Time for another programming concept, this time observer design pattern. This isn't the first design pattern that we've looked at in this course. Indeed, we're starting to develop an understanding of a few of these design patterns, which is a really strong thing for you as a developer, as most of these design patterns transcend almost all of programming. They apply across the languages, across the platforms. So what is the observer design pattern all about? Well, sometimes we want to respond to a continuous stream of events. Typically in the past, when we fetch some data in our app, we just get it as a one-time thing. Get my running records, get my tasks. But sometimes we're interested in a type of data which can emit multiple events over time. For example, think of the news, and particularly the news headlines or breaking news updates. If you're somebody who follows the news, checking the news isn't a one-time thing. News stories are happening all the time. Now, you may check in on the news at various intervals. You might read the newspaper in the morning, you might visit an online news site at various points in the day, or you might watch a specific program. Or perhaps you have notifications turned on your phone. So whenever there's some new breaking news in your area, you might get an alert. But the fundamental idea is that news events happen multiple times, over and over again, over time. And you won't be the only person paying attention to the news. It's not just for you. Multiple consumers might want the events, whether this be news or train times or stock market prices. So there's one source of the event, be that the news agency or the train station or the website with the stock market prices, one producer of the events, but multiple consumers. You can see in this silly drawing, one producer of the events, and then multiple people interested in the events, multiple consumers. And whenever new events happen, all of those consumers, all of those people interested in the events want to be notified about it. Now, in code, how can we go about having a single producer of events, a single source that might emit things that the consumers are interested in? Well, how might we go about doing this in code? Well, one way to notify all of the consumers would be that the event producer notifies them directly. So the bit of the code where we emit the events, well, that thing would hard code every single person who wants to be notified. And it might look a bit like this. Imagine your news agency. They might have various new headlines happening throughout the day, and they might hard code the various places that need to know about that. Update the TV, update mobile app, send an email. And while this would be reliable in getting the updates to all the people who care about it, it's not ideal. Every time there's a new consumer or somebody else who wants to be notified, well, you'd have to change the code in the producer itself. That won't scale well as the app grows. That won't be maintainable when large amounts of consumers are interested in this. And indeed, it's not flexible to allow anybody to subscribe to the news. You would have to know beforehand. So that's no good. Another approach could be that the event consumer just constantly checks for updates. Think about in our tasks app, how whenever we do a change like update or delete a task, we're manually fetching the changes to see what's changed. That kind of thing. So in code, it could look something like this. Rather than the news agency, it's now a news reader, a news consumer. They might have a function to check for the news, they might have access to the news agency, and they might have some sort of infinite loop. You can see there, while true. And that'll go round and round, and every time it goes round, we're checking, is there any new news? News agency dot has new news. And if there's nothing new, that'll be false, so then nothing happens. But whenever there's new news, well, we're constantly checking, and so that would sometimes be true. And then in those moments, you would get the new news. But that's also not ideal. We're making it the responsibility of the consumer to constantly check, have you got anything new for me? Do you have any new events? You can imagine there'd be a piece of code like this running over and over again, and that's quite inefficient. You shouldn't force your consumers of the events to have to keep on checking manually, just like we're having to do in our tasks app by manually calling fetch tasks every time we do an update. So neither of these approaches are suitable. The other approach is to let consumers register themselves as observers. You have a single producer of the events, be that a news agency or a train station or a weather report, and there can be something in the code that allows any consumer to say, I would like to subscribe please, hold on to me so that whenever you have any updates, you know who to send the update to. This is not too dissimilar to the way our click listeners work with buttons. A button can have multiple listeners, and you simply register yourself as a click listener. And then you can add multiple click listeners, and then whenever the button is clicked, it will notify all of the listeners. That is the observer pattern. We looked at that before in the concept of callbacks, but that is actually the observer pattern in action. There would be a single subject that emits events, and anybody who's interested can subscribe. They do that themselves, it's a one-time thing, and then they will get notified whenever there's a change, in real time. We've been doing that in the past using callback code. Indeed, that's how button click listeners work. You're subscribing, you're saying, hey button, please let me know of any click events, and then we give it a bit of code, a callback function, which is accessed every time the click listener fires. It's a similar concept. So then, if we've kind of covered the idea of observer pattern before, with our click listeners, and the idea of callback code, and in the last tutorial, if we think how we're wanting to avoid some of this ugly callback code pattern and go for something better, how can we take this observer pattern further? And the answer is with a concept called reactive programming and the idea of streams. So rather than giving our event producer a function to call, this callback code, we can instead do a style of programming where we react to any changes. And there's a few very common and popular ways of doing this, some widely used libraries that make this very easy. And the idea of reactive programming goes hand in hand with the idea of streams or event streams. This would be a sequence of events happening over time, a stream of events, a flow of events. It might look something like this. Imagine now a train station, and you can imagine a line going from left to right representing time. Well, the first event that might happen from our train station is a train depart event. The 10:20 a.m. train to London from Leeds has departed. That would be an event that you might want to be notified of. Then, after some time, another event might come through, a minor delay. Then you might get another notification for a new event, a platform change. And then the dreaded event, the train cancelled event, could come through. I'm not going to lie to you, this is pretty typical of most train stations here in the UK on most days. This is a pretty good example of the way trains are at the moment. But it would be a stream of events over time, a flow of events, and you would want to react to any of those happening. So how could the idea of an event stream and then reactive programming where you react to those events look? Well, a little sneak preview of Kotlin Flow, which we'll be looking at very soon, it could look like this. So the top there would be our event stream, our flow of events, our stream of events. Stream, flow, synonymous really, events happening over time. And this stream or flow might emit events one after the other, potentially with some delay or time between them. You might have a train departed event, a minor delay, platform change, and then the train cancelled. So the 4 events are happening in the flow at the top, a flow of events, a stream of events. And then in the bottom function, observe train updates, our observer design pattern, you can see now how this is all tying together. Well, we simply just collect those events. We react to them. This is reactive programming. We have a single thing that can emit events over time, our train updates flow. This is an event stream. And we can simply, in code, collect all of the events that happen for as long as they happen. And you can see we have that lambda with the update variable there. So whenever there's a new event, we're going to collect that. We're going to react to that, and we're able to print that update. This is reactive programming. Reactive programming is a way to do the observer design pattern, a very clean way which doesn't rely on callback code. Hopefully you can see the power of this reactive programming, of observing events over time, and being able to do something when those events happen. Now, that is a sneak preview of Kotlin Flow. It is the most modern way to do it in Android and Kotlin at the moment, and it is the way we'll be doing it in this course. It is worth mentioning, there are previous versions of it. RxJava was an early implementation of the idea of reactive programming. It does work for Kotlin too. I think they might even call it Rx Kotlin, but this was a similar approach of having a stream of events that you can react to. Then live data became the first official Android library, produced by the team at Android themselves. It was a way to emit events, live data, data that is happening live. But when Kotlin Flow came along and became mainstream, well, the syntax and style of Kotlin Flow is so clean, it performs so well, and it works perfectly with suspend functions and coroutines that really, today, it is the best way to do reactive programming in Android. So, in detail, the observer design pattern, an idea that we've already seen before, but it introduces a new sophisticated way of doing the observer design pattern through reactive programming. And we've had a sneak preview of Kotlin Flow as a way to do reactive programming, as a way to do the observer design pattern. And so in the next tutorial, let's now put this into practice and start to work with Kotlin Flow. So let's add reactive programming into our developer skill set by using Kotlin Flow right now. It can seem like a slightly daunting concept, this new flow type. I certainly remember that feeling. It sounded like an advanced concept. However, in the previous tutorial, we see how it looked like in practice, and it's not a terribly large amount of code. Before applying it to our database, we'll first have a little play just to explore it, to see how simple the code is for it. I've got 2 files open, the tasks fragment and the tasks view model. And what we'll do is, rather than doing anything fancy with the repository or doing anything with our tasks for now, we'll just create a flow inside the view model. We will emit some values, we'll simulate a delay between them, so we're making a pretend stream of events, an event stream, and then we'll just consume that in the fragment. So let's make a new function, and it does not need to be a suspend function. The suspend context is within the flow itself. That might sound confusing, let me show you what I mean. So we'll do a function called getOurFirstFlow, or something silly like that. We'll leave the return type for now, we'll add that later on. And in recent versions of Android Studio and Kotlin, just like with coroutines and suspend functions, this flow type comes as part of the Kotlin X coroutines library. It comes for free by default. So we can make a new variable called OurFirstFlow, and we can make that equal to this useful little syntax of flow with a lowercase f, and then you see that lambda there, where it says block suspend flow collector and autocomplete. And we'll make this of type string. We'll just emit a sequence of strings that we can collect in the fragment. And then we'll make a few line breaks in this block, and this is where we can emit the values. This is where we can do our event stream. Okay? Now, I said to you that we did not need to make this a suspend function. You can see if I add that, suspend is grayed out. Just to show you, if you command click on the word flow with a lowercase f like this, and we scroll down a bit, so it's a function fun flow, and then the lambda is this block of code that we fill out, and that is a suspend function. Okay, so this thing here, this suspend block is this block here. So we are now working in a suspend function, which means we can do things like delay for 5 seconds. We couldn't do that if we were outside of a suspend function, okay? So we have this suspend function here where we can write long-running code. And the way you publish a new event, the way you emit a new string, is simply with the function emit. So we can do hello from our first ever flow, exclamation mark. And then we can put a delay in of, say, 5 seconds or 6 seconds, something like that, something long. And then we can emit something else. And you can think of this like simulating an event stream. These events might be coming from a web API. These events might be coming from changes to our database. There's all sorts of use cases where you want to observe something, observe an event stream, and then react to it, particularly with data that can change frequently over time. So we're simulating that here. So now we can say, after hello, something like, here is our second flow update, exclamation mark. We'll do another delay of maybe something shorter, 5 seconds, and we'll emit something else. And here is our final update, comma, for now. So just like in the previous tutorial, This is now our event stream. This is the thing that we want to observe and react to. Flow is reactive programming, so when you have a flow, you can react whenever there's any update to it. Now you'll see that the type, the diamond bracket string, is now grey. Because we're emitting only strings, it knows it's a flow of strings, so we can go ahead and do Alt-Enter, Option-Enter, and remove that. Nice and simple. So a very simple syntax just to make a new flow and then emit things. If I click on the variable and do Alt-Enter, Option-Enter, and specify the type, it's a type called flow. Not list, not array, but flow. And a flow means multiple values can flow out of this. An event stream, a flow of events, okay? So we will go ahead and just return this. So return our first flow, and I'll use the error to do Option-Enter and change the return type. So we're returning now a flow of type string. So we can head back now to the tasks fragment and actually consume this. Now we saw that that function itself wasn't a suspend function. It's the flow collector block where we do all the emissions that is the suspend function. So even though we didn't need to make the viewModel function suspend, well, when we respond and react to flow values, when we collect them, as you'll see in just a moment, that does need to be launched inside a coroutine or suspend function. So what we'll do is, in our lifecycle scope, we'll go ahead and fetch the tasks and then set them on the adapter. But then underneath this, still in our same lifecycle scope, we will also do viewModel.get our first flow, and then we will write some code to respond to the values here. So how do you receive all the updates to a flow? Well, there's a few ways. One that's called collect and another that's called collect latest. I don't want to do a big deep dive into the difference between those two things now. However, for the majority of use cases, particularly in the UI layer, in our fragments, activities, and Jetpack Compose later on, usually collect latest is the most useful. What that means is if we had a delay here for some reason, like another delay of 10 seconds, and then this flow was emitting lots of values in those 10 seconds, well, we would only respond to the latest value. And when it comes to showing things in the UI, like for example our tasks, well, we don't really need to quickly fire through 3, 4, 5 different updates. We only ever really care about the latest version of the tasks. So a quick tip for you, usually in the UI layer, collect latest is absolutely fine. You can find many a Stack Overflow answer that will explain in detail the difference between collect and collect latest. We could use either, but we'll use collect latest because we have this nice little lambda you can see there. And if you look, the thing we receive in this lambda is a string. So I'm going to call this string our update. I'm going to name it. And now we can just display this. We'll do something very simple like a toast. So toast make text, require context because we're inside a fragment. And then we'll simply make the message be the update. And then we'll do toast.length short. Don't need to see it for too long. Not forgetting .show. And that is it. So to recap, you can create a flow with this useful little flow block, lowercase flow, and then emit things. You can emit multiple things. And this block returns a variable of type flow, a flow of string, a flow of task, or even a flow of list of tasks. Okay, so it can be a flow of anything. Depends what you emit as to what the type is. But flow is a new type, like a list, like an array, but now it's a new thing called a flow. And a flow will emit a sequence, a flow of values. And to react to them, you collect them. And here we are. We're getting our first flow, and then we're calling collect latest, saying we only really care about the latest value. So let's go ahead and run this now and see what happens. Now it's a new thing called a flow, and a flow will emit a sequence, a flow of values. And to react to them, you collect them. And here we are. We're getting our first flow, and then we're calling collect latest, saying we only really care about the latest value. So let's go ahead and run this now and see what happens. Okay, we have the first toast. Actually, just before I run it, I'm going to change the length from length short to length long, so I've got enough time to move some of the stuff out of the way. And I think in the flow, I will do a little delay before the first emission. So we'll delay for just a couple of seconds to give me time to clear off all of the pop-ups that cover the toast. Okay, so now we can run this. We'll wait for 2 seconds. We should see our first value, and there should be a 6-second delay to our second one, and then maybe something shorter, a 4-second delay before our final toast. So let's now run this. So I'll close that down, a couple of seconds. Our first emission, hello from our first ever flow. That'll go away. And then our second flow update after 6 seconds there. And then the last one. Here's our final update for now, after a shorter 4-second delay. So that's pretty much it for flow. For reactive programming, we can create flow types that can emit one or multiple values over time, and then we can collect them. Quite easy, really. Whenever we collect a flow, it needs to be in some kind of coroutine. So for now, we're just doing this inside our lifecycle scope. But the actual flow itself, well, we don't need to make the function suspend. It's actually this block here that is the suspend block. The flow thing itself is fairly safe. It's just a variable type. So if that then is a quick flyover of creating a flow and then collecting it, well, where does this fit in with our tasks app? How does it work with Room? And so in the next tutorial, we'll explore how the Kotlin flow type works with the Room database, and we'll see how the Room library is tailor-made for working with the flow type. So let's do that next. Time now to apply the concept of flow to our real use case by using it in our database and the Room library. I'm just going to very quickly remove the test flow we just did in the previous tutorial, so you can go ahead and do that. We can remove this function for now. If I just close the emulator, and if we head to our repository, So task repository, I'll command click on that. And then if we head all the way over to our task DAO, by command clicking on it, we can make our change here. Now, if you remember, before we had coroutines and suspend functions, well, this task DAO interface was just fun create task, fun get all tasks, etc. Okay? And we discovered that if we add the suspend operator, then Room under the hood would do all of the work for us to make these functions run within a suspend function. So I'll just undo to put all of those back in. Well, it's the same concept for Kotlin Flow. In fact, the Room database has been built to work with either Kotlin Flow or the slightly older Live Data, both of which are reactive programming libraries. All we need to do is change the return type from the plain type, which in our case is a list of tasks, to one of the reactive types, either Flow or Live Data. So if you can go ahead now in your task DAO, and rather than returning a list of tasks, return a flow, and then left diamond bracket, a flow of list of tasks, and you'll need to put another diamond bracket at the very end. And we'll go ahead and import that with Alt Enter Option Enter, being sure to select kotlinx.coroutines.flow, and that is it. Just to be clear, you need to make sure you have the diamond brackets for flow, and then within that, a list of tasks. So you can have a couple of diamond brackets there, and then you're going to have two at the end. Just be careful there. It won't work if you miss one of those brackets. So getAllTask now returns a flow of type, list of type task. So just specifying the different return type will make this work. You could also change it to Live Data, but that's an older reactive library, and most modern Android projects today aren't really using this anymore, as Flow is so much better in Kotlin projects. But I just thought I'd show that. So whichever return type you specify, under the hood, with these annotations, the Room library will take care of generating the code for us. So rather than a one-time list of tasks, it will now emit a new list of tasks anytime it detects a change in the task table. How good is that? So whenever there's any change from anything, adding a new task, updating, deleting, well, the database will know about it, and it will emit a new list of tasks for us. A constant stream of task updates over time. In fact, in the next tutorial, we'll even take a little look into the code to see how it does that. But for now, we can now work with this flow type. So let's trace our way back from our data source up to now our repository. So now we need to change the return type from list of task to flow list of task. Now you could do it the manual way like I'm doing here, by wrapping it in another flow and the diamond brackets, that's okay. Or, if I just undo that, you can use the error, do Alt Enter Option Enter, and change the return type to the correct one. That also works. And we should be able to get rid of the word suspend. If I remove it, well, it's complaining because the task now is suspend, but if I command click on it, we can simply remove the suspend word from this one. We must leave the suspend word for the create, update, and delete tasks. That needs to run in a suspend function within a coroutine. But now, as we're returning a flow, and the suspend code block is kind of within that flow builder that we saw in the last tutorial, Room will be doing that under the hood. Well, we don't actually need to make the function a suspend function. We just need to collect the flow in a coroutine. Okay? Don't get too confused by that. Just be happy that we don't actually need to make the getAllTask function suspend because we're returning a flow. And then in the task repository, now that's fine. You will see if I had the word suspend there, it's not needed. So that is the change to our task DAO. That's the change to our task repository. We're now returning a flow of list of tasks. Let's command click on the getTask function to see where that's used, and it's used in our tasks view model. So again, we can change this return type to a flow. In fact, I'm just going to return it directly. No need for the local variable. So you can see that we're simply returning the repository.getTasks. The type is now a flow. We can remove the suspend operator. And so now, if I command click on fetch tasks to go all the way up our architecture to our fragment, or we can remove the suspend operator. And so now, if I command click on fetch tasks to go all the way again, we can change this return type to flow. Fine. You will be happy that we don't actually need to make the getAllTask function. That is the change to our task DAO. That's the change to our task repository. We're now returning a flow of list of tasks. We saw in the previous tutorial how a data layer is usually a good idea in modern Android architecture. You may have thought that now that we have a view model already, that would complete model view model. But if we're being disciplined, really the complete MVVM architecture does include a data layer. And typically that's called a repository that may depend on a database, or a repository that may depend on a web API, some kind of data source. We saw that in the previous tutorial. If you look at this tasks view model, this view model is interacting directly with our task DAO, our data access object. And this is very much a database thing. If I command click on the task DAO, well, I can see that we instantiate it from the database. And really, the UI layer, that is our fragments, activities, and view models, they shouldn't be interacting so directly with the actual data source. So we will go now and introduce a repository, and so the view models will then interact with the repository. The view models, the UI layer won't care what the data source is. Doing this will complete the MVVM architecture layers. So on the left, I can see I have a data package, and in it I have my database, my task model, and then the task DAO, which relates a bit to the database. It's the way we access the data objects. So to clean things up a bit, let's separate the fact that we have our model here, the task, the first M in MVVM standing for model. We'll have a package within here for the model, and then we'll have a separate package for the database, our specific data source, and then we can introduce a repository class, and that'll be the only thing that the UI layer interacts with. So I will right click on the data folder, do new package, and first of all call this model. So our task model can go into there. I'm just going to click and drag that to move it in. Refactor, that's fine. So we have our model, MVVM. I will also make another package that represents our specific data source. In this case, we're using a database. So I will right click on data again, do new package, and call this one the database. And I will move both the database and the task DAO. I'll use shift to select both of those, and I will drag them both into the database folder and refactor. So all database stuff in the database folder, our simple plain models in the model folder, and then now in the data folder, we can do one class, so new Kotlin class, and we can call this our task repository, a simple repository class. This is the convention in MVVM, that the public thing that the UI layer or domain layer interacts with in MVVM is the repository, and everything else, such as the specific data source, is hidden away from the app. The app shouldn't care about that. And thinking about what we might need to give this task repository, well, we can just give it the task DAO. So we'll do private val our task DAO of type task DAO, and the convention in MVVM in class, so new Kotlin class, and we can call this simple plain models in the model folder, and then now in the data folder, we can do one class, so new Kotlin class, and we can call this our task repository, a simple repository class. This is the convention in MVVM, that the public thing that the UI layer or domain layer interacts with in MVVM is the repository, and everything else, such as the specific data source, is hidden away from the app. The app shouldn't care about that. And thinking about what we might need to give this task repository, well, we can just give it the task DAO. So we'll do private val our task DAO of type task DAO, and then in here we can do plain and simple functions. So let's think about what functions we need. I'll go to my tasks view model. We need one to get all tasks, we need one to update the task, one to delete task, and over in the main view model, one to create a task. So pretty much create, read, update, delete, CRUD. So let's do exactly that in the repository. So we'll do a function to create task. We can give it the specific task model now, that's okay. We will do one to get tasks, and that can return a list of tasks. We'll leave the error for now. We can do one to update the task. That will also need a task. And we can do one to delete the task. And that will just, again, need the task. And then the repository will defer to our specific data source, which is our database, via the task DAO. So short and simple, we can now do task DAO dot create task, giving it a task. Now we have an error saying a suspend function can only be called from a coroutine or another suspend function. If we command click on our DAO methods, our DAO functions, they are all suspend functions. So the beauty of coroutines and the beauty of suspend functions is we can just make this another suspend function. We can make launching the coroutine the problem of the view model. The repository doesn't care about coroutines, so we will make these all suspend functions. And then taskDAO.getAllTasks, we can actually return that and the error will go away. We can do taskDAO.updateTask, give it the task, and then taskDAO.deleteTask and give it the task. And hopefully you see how clean and tidy this repository class is. It exposes simple functions that either return things like a list of tasks or just require things like a task to create, update, or delete. This is all the app will see. The UI layer in the app doesn't care that we're using a task DAO. If later on we move to a cloud database or Firebase or something like that, we could swap out the data source, but leave these functions exactly the same. And this is where the flexibility part of an architecture comes into play. So we now have a repository. So this is the thing that the UI layer will interact with. So if I go back to our tasks view model, I'm going to remove the task DAO now. We don't want to interact with this. Instead, we're going to interact with a repository called a task repository. And we should probably access it the same way that we accessed our task DAO, and that was from the application class. So let's now make a new later init variable, which is now our task repository. And then we can initialize it to make a new this. We could swap out the data source, the equal function, and then taskDAO.delete. Task and give it the task. And hopefully you see how clean and tidy this repository class is. It exposes simple functions that either return things like a list of tasks or just require things like a task to create, update, or delete. This is all the app will see. The UI layer in the app doesn't care that we're using a task DAO. If later on we move to a cloud database or Firebase or something like that, we could swap out the data source, but leave these functions exactly the same. And this is where the flexibility part of an architecture comes into play. So we now have a repository. So this is the thing that the UI layer will interact with. So if I go back to our tasks view model, I'm going to remove the task DAO now. We don't want to interact with this. Instead, we're going to interact with a repository called a task repository. And we should probably access it the same way that we accessed our task DAO, and that was from the application class. So let's now make a new later init variable, which is now our task repository. And then we can initialize it here. The task repository equals the task repository, and we give it simply the task DAO. So in fact, we probably shouldn't even make the database and the task DAO available to anywhere else in the app. So I'm going to remove these global properties that we have in our get application class, the task repository. And we should probably access it the same way that we accessed our task DAO, and that was from the application class. So let's now make a new later init variable, which is now our task repository. And then we can initialize it here. The task repository equals the task repository, and we give it simply the task DAO. So in fact, we probably shouldn't even make the database and the task DAO available to anywhere else in the app. So I'm going to remove these global properties that we have in our getItDoneApplication companion object. I'm going to delete these and just make the repository the one thing the app can access. So instead, we'll make these a local variable. So there's our database and there's our task DAO. And we just internally here give the task DAO to our repository. And this is the one thing the app then interacts with. So if I go back to my tasks view model, we now have an error for this task DAO because we can't see it. So we will just have the repository, and that can equal our getItDoneApplication.task repository. And so now we can swap these things, repository, get tasks. Repository.update task, repository delete task. And where else do we need to do this? In our main view model. So again, we won't refer to the task DAO anymore. Instead, we will only interact with the repository, our task repository. And that can be located in the application task repository like that. And so now it is repository.createTask. So I'll just keep the two view models side by side, and then the repository. I'll close everything else down just to recap that. So we've introduced a new layer, the repository, the entry point of our data layer. We've even tidied up our data folder, so we have the task repository at the root of the data folder, and now the database is hidden away. It's one of our data sources, but the app, or certainly the UI layer, can't see that. Or at least we don't instantiate it and make it available to the fragments and activities. Only this task repository. This is the data layer. It has handled made ourselves a MVVM data layer in your form of us fixing one or two final little bugs to do with the way that we refresh our tasks when things change. So let's do that next. Time now to apply our task DAO. That's the change to our task repository. We're now returning a flow of list of tasks. Let's command click on the get task function to see where that's used. And it's now, as we're returning a flow, and the suspend code block is kind of within that flow builder that we saw in the last tutorial. Room will be doing that under the hood. Well, we don't actually need to make the function a suspend function. We just need to collect the flow in a coroutine. Okay? Don't get too confused by that. Just be happy that we don't actually need to make the getAllTasks function suspend because we're returning a flow. And then in the task repository, now that's fine. You will see if I had the word suspend there, it's not needed. So that is the change to our task DAO. That's the change to our task repository. We're now returning a flow of list of tasks. Let's command click on the getTask function to see where that's used. And it's used in our tasks view model. So again, we can change this return type to a flow. In fact, I'm just going to return it directly. No need for the local variable. So you can see that we're simply returning the repository.getTasks. The type is now a flow. We can remove the suspend operator. And so now, if I command click on fetch tasks to go all the way up our architecture to our fragment, well, you can see now we have a problem because we're expecting a list of tasks, but actually this is returning a flow. So let's go ahead now and delete all of this code inside our lifecycle scope coroutine, and instead do viewModel.fetchTasks.collectLatest. And you can see in this lambda, it corresponds to a list of task, not a flow of list of task. This thing is the flow, and we're collecting it. And when you collect a flow, you collect the type of the flow, which is a list of tasks for us. So I can just go ahead and call this tasks for clarity, auto format. So whenever there's an update to that flow of list of tasks from the database, we will receive the updated tasks just here. So let's go ahead now and do adapter.setTasks, pass in the tasks, and that is it. We can delete fetch all tasks from the onTaskDeleted function. Whenever we make any changes to the task table, this is going to fire automatically. So I'm going to remove the fetch all tasks from there. I'm going to remove the fetch all tasks from here. In fact, we can remove this code block altogether, and we can head into update task and delete this silly onTaskCompleted block. We don't need this anymore. We will just simply do viewModelScope, launch, update the task, and the room database is observing the table. It is ready to emit a new value in that flow whenever it detects any changes. So back to the task fragment, no need for fetch all tasks. We are collecting the flow. And if we command click on fetch all tasks, we can see that we're calling this from main activity. So we actually don't even need to have this code here, because whenever we make a new task, well, fetch all tasks, any changes. So back to the task fragment, no need for fetch all tasks. We are collecting the flow. And if we command click on fetch all tasks, we can see that we're calling this from main activity. So we actually don't even need to have this code here, because whenever we make a new task, well, that's going to be a change to the task table. So that flow will emit automatically. So we can actually delete the fetch all tasks function call there. And we can even delete holding onto the tasks fragment at all. We can delete that because we only need that in one place in our pager adapter. So we can return a tasks fragment directly here. And now nobody needs to call update tasks, fetch all tasks. Because we're using Kotlin Flow, this is going to happen automatically whenever there's a change to the tasks table here in our task DAO, all because we're using the return type of flow. It will be an event stream, a continuous flow of changes to our tasks table. In fact, back in the task fragment, we're even being told we can make this private now, which is much, much better. Okay, let's run this and make sure it works as expected. Well, the first bit of good news is we have our tasks. So this is definitely working one time, but let's see what happens when we start to do things. Let's create something. This is happening in main activity. My task from main activity, and save. And we see it there, where my mouse is. In main activity. My task from main activity, and save, and we see it there where my mouse is. Let's check off a task, do some stuff, goes to the bottom. Let's quickly check all 4 of them off. Check, 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 check. And let's uncheck a few things. Uncheck, 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 uncheck. Everything is working. And let's delete a task by long pressing it. Our little special debug thing to remove tasks. Long press, disappears. Disappears, disappears. whenever there's a change to the task table, this flow automatically emits. We collect the latest list of tasks all the time, just with this small bit of code. How good is that? So maybe a little bit to take in there. If I head back to the task DAO, all we've really changed is the return type from a list of task to a flow of list of task, and then in the fragment collecting it. That's really the only code change we made. So how does this work? How do we suddenly get automatic updates? And the answer is, it is happening under the hood as part of the Room library. Some of the code is a little bit complex. However, when I first started using Flow with the Room library, I was really confused as to how it worked. And so in the next tutorial, we'll take a very short look at some of the generated build code. We saw that when we first made our database and we first learned about SQL. We saw some of the SQL code that the Room library writes automatically from this. We can do a similar thing, and while a lot of it is going to seem very confusing, we're going to see some key things. We're going to see how the database notifies when there's a change to the table, and we're going to see some of the Flow library code, as well as seeing things being omitted. So in the next tutorial, let's take a very quick dive into the generated code to